When metal parts move against each other, friction causes heat as well as wear and seizure. But if there is a film of oil between them, friction is reduced, movement becomes smooth, and heat and wear are significantly reduced. This effect is referred to as lubrication, and the oil that protects two metal parts from each other is referred to as the oil film. In both the two-stroke and four-stroke engine oil is distributed to its moving parts for lubrication. Lubrication reduces friction and frictional heat, increasing the efficiency of the engine and reducing part wear due to frictional heat. There are differences between the lubrication systems of two-stroke and four-stroke engines. Let's look at the different parts and structures for these systems. First, we'll take a look at the lubrication system for the two-stroke engine. Most Suzuki two-stroke engines distribute fuel and oil separately in what is called the Suzuki CCI system. An exception to this is the RM series, which are models made for racing. In the engines of these motorcycles, oil and fuel is distributed together in what is called a fuel-oil mixture. This diagram shows the basic flow of lubrication in the Suzuki CCI system. Oil is pumped out of the oil tank into the inlet manifold with the oil pump. It enters the crankcase chamber together with fuel-air mixture from the carburetor. The oil is mixed with the fuel-air mixture and lubricates the big end of the conrod and its bearings around the crankshaft, as well as the piston and cylinder walls, and is eventually burned together with the fuel-air mixture, the resulting gases being expelled as exhaust. Engine oil is stored in the oil tank. This tank is equipped with a device to check the remaining amount of oil in the tank. If the oil level becomes low while the engine is running, an indicator light lights up on the instrument panel of the motorcycle. Most two-stroke engines use a mechanical oil pump, which is designed to provide the necessary amounts of oil to places where it is needed in the engine. Because the amount of oil necessary is determined not only by the revolutions per minute of the engine, but also the amount the throttle is opened, the control cable must be synchronized with the throttle valve. Now let's look at the lubrication system for the four-stroke engine. Suzuki four-stroke engines use systems in which oil is stored in the crankcase and in which oil is stored separately in an oil tank. The first type is referred to as the wet sump system. The second type is the dry sump system. Most Suzuki four-stroke engines use the wet sump system. There are slight differences in wet sump systems used for different types of motorcycles. But the diagram you see here shows the basic arrangement for the wet sump lubrication system. As the engine turns, the revolving crankshaft drives the oil pump drive gear through a system of gears. When oil is pumped up from the pool in the crankcase, it passes through the oil sump filter to remove foreign matter. This oil then passes through the oil filter to be cleaned further. After cleaning, the oil passes into the different lines that lead to the parts that require lubrication. Oil goes through the counter shaft and the drive shaft and goes on to lubricate the clutch plates and the transmission gears. Oil also goes through the crankshaft and out the oil discharge holes to lubricate the crankshaft bearings, conrods, pistons, cylinders, etc. The oil from the other line that branches off goes through the oil line in the cylinders to the cylinder head, through the camshaft, and is discharged to lubricate the bearing area of the camshaft, the rocker arms, and the cam chain. Oil that has fallen from lubricated parts goes through the return line back to the pool of oil in the crankcase to be pumped through the system once again. The four-stroke pump is usually a trochoid pump which is composed of an inner and an outer rotor. It is also made so that the oil filter can be replaced. Lastly, let's take a look at the different types of oil used for lubrication. There are two ways that types of oil are classified. There is the Society of American Engineers, or SAE classification, and the American Petroleum Institute, or API classification. The SAE classification is performed according to the viscosity of the oil. Engine oil viscosity changes as its temperature changes. Thus, it is necessary to choose an oil that fits the temperature conditions under which it will be used. The 10W40 grade has a high viscosity index and can be used in a wide range of external temperature conditions. It is thus referred to as a multi-grade oil. The API classification is also referred to as a service grading. Rather than being based on viscosity, API grading is an overall classification that takes into consideration type of engine and conditions the oil will undergo during use. This grading is used most commonly. There are now 7 grades from SA to SG, and the closer to SG, the higher the grade of oil. However, because many additives are used, each manufacturer usually makes recommendations for what oil grade is best for its engines. Engine oil eventually picks up impurities, loses its lubricating characteristics, and is consumed through some burning. It must be checked regularly and periodically changed to make sure that the engine is receiving adequate lubrication. The oil filter must also be changed regularly.